Hello everyone, this is Madam Lee, and in this video, we will be moving on from finding the similar area ratio to discussing about the volume ratio for similar solids. So when we talk about volume, we usually refer to 3D diagrams. So now let's look at these two solids, and in this case, the investigation it is two cubes. So cubes have three dimensions, okay, that are the same. So therefore, they are similar. Now, to find the volume of the small cube, since the length given is L1, so the volume will be L1 cube. If you look at the big cube, each length is given to be L2. So to find the volume, this will simply be L2 cube. So if we take the ratio of both the volumes, we will get L1 cube over L2 cube. So I can also take out the cubes and rewrite this as L1 over L2 bracket cube. So to conclude, the ratio of volume of similar solid, okay, it has to be similar, is equal to the cube of the ratio of any two corresponding lengths of the two solids. So when we say corresponding length, it means the length that are matchable. Okay, so if it's height, the other one will take height. Okay, if it's breadth, the other one will take breadth. Okay, so that's what we mean by corresponding. If V1 and V2 denotes, okay, there's something wrong with there's a typo error with the notes. Can you change this to volume? So if if V1 and V2 denotes the volume of two similar solids, and L1 and L2 denotes their corresponding length, we can make ourselves a formula where V1 over V2 is L1 over L2 bracket cube. Okay, so just a recap, for area, similar area, it was L1 over L2. It looks very similar, but instead of a cube, it was a square. But when it comes to volume, it is L1 over L2 over whole thing cube. Okay. Now we are going to go through example 6 to example 9 to apply our similar volume ratio. So let's look at example 6 first. Okay, so for example 6, it says find the volume of the similar figures. Okay, so the question has to first tell you the condition that they are similar. So if they never tell you it is similar, you cannot assume that it is similar. In this case, since they are similar, I'm supposed to, for the first one, find the volume of the smaller cube. So I will say that V, okay, the small cube over the larger cube is 2 over 3 cube. Okay, so by multiplying both sides with 27, I can find the smaller volume to be 8 over 27 times 27. And therefore, the volume is 8 cm cube. Okay, so again, it doesn't matter whether you put 27 first or you put the small volume first. If you decide to put the small volume first, you have to start with 2. Okay, if you decide to put 27 as the numerator, then here on the other side of the equal, we will start with 3 over 2. Okay. Now in the next diagram, we have a cylinder. Okay, the ratio of in this case, they are similar figures, okay, given in the question, and we are supposed to look for the volume of the smaller cylinder. So we are given a pair of corresponding height of the cylinder. So let's try to apply the formula now. The volume of the smaller cylinder over the bigger cylinder is 1 over 3 cube. So if I multiply both sides by 500, I can get the small volume to be 1 over 27, expanding the bracket, multiplied by 500. Okay, and therefore the answer is 500 over 27 cm cubed. Okay, so you can simply leave it as a fraction because it is an exact answer.
Now let us look at example 7. In example 7, it says that we have a model of a tower and the scale is 1:100. So when we say model, okay, it is a replica of the actual tower. So already it means that the model and the actual tower, they are similar solids. Okay, it continues to say that the tower has a volume of 900 meters cubed, and later they want you to find the volume of the model in cubic meters. So it means that the volume of 900 meter cube here given is already the actual volume. And what they want us to look for, okay, the units is also meters cube. Okay, so let's begin to apply the formula. Okay, so when we are given a scale of 100 is to 1 is to 100, this is what we call the corresponding length scale. That means 1 cm of the model is equivalent to 100 cm for the actual tower. Of course, the unit doesn't only have to be cm. It can also mean that it is 1 meter is to 100 meters. Okay, or 1 km is to 100 km. So the units is not given in the ratios, the scale ratio, because it can actually be any unit that you want. Because as long as they are the same units, actually you can see it as they divide each other. And therefore, all you're left with is 1 is to 100. So depending on what the question is using, in this case, they are using meters cubed. So I will be referring it to 1 meter represents 100 meters. Okay. Anyway, when I apply the formula, what I really need is just 1 over 100. Okay, with a cube. And because they are similar volume, I can put V model, okay, the smaller volume, over 900 equal 1 over 100 whole thing cube. So in this case, to find the volume of the model, I will just be using 1 over 100 cube multiplied by 900 to obtain the volume of the model in meters cube or cubic meters. Okay, so please go and do the calculation on your own. Now we are going to look at example 8. Okay, in example 8, we are given the volume of a sphere, which is 50 cm cube. Okay, so a sphere is a circular solid, and the volume is given. And it is mentioned that the volume of this 50 cm cube sphere is 1/8 of another sphere. So this is only 1/8 of another sphere, meaning that we have another bigger sphere that is 8 times larger in volume as compared to the 50 cm cube sphere. Now the question here is, what is the surface area of the bigger sphere? And the formula of the surface area is also provided. Now if you look at the formula of the surface area, what we really need is just the radius. So in this case, as long as we can obtain the radius of the larger sphere, we will be able to get the surface area of the larger sphere. Okay, now there are different ways to do this. And in fact, I don't even need to apply the similar volume ratio for this question. Now, though the spheres are always similar because really there is just one dimension that is forming the volume. Okay, if you know the volume of a sphere, it is 4/3 pi r cubed. Okay, so there is really just one dimension, the radius, that is guarding my volume and as well as the surface area of a sphere. So a sphere is always similar. But in this case, I can straight away find the volume of the bigger sphere just from multiplying 50 by 8. Okay, so this 400 cm cube, I can equate it to the volume formula and work backwards to find radius. So to find the radius, let's bring the constant 4/3 pi over and do a cube root to get the radius. If you are to calculate this on the calculator, you're going to get 4.57078. So I'm giving it a little bit more accuracy by leaving it to 5 decimal place, because this is not the final answer. The final answer, well, what they really want is the surface area. So now that I have the radius, I can find the surface area for the bigger sphere by applying the formula 4 pi r squared. Okay, so by pressing this on the calculator, you should be getting the answer 263 cm square, round off to 3 significant figure. Okay, now let us look at example 9. In example 9, a carpenter cuts a wooden cone into 3 parts, A, B, and C. And it is mentioned that the planes that are cut are parallel to the base, as shown in the diagram. So what it really means is that the radius here, they are all parallelly cut to each other. So if you drop down a height from the vertex, what we're looking at, they are our similar triangle in a 2D plane. Okay, so it is mentioned that the height of the 3 parts are in equal portions, meaning that we are also looking at the ratio of 1 unit to 1 unit is to 1 unit. Now in part A, they want us to find the ratio of the volume of A, B, and C. Now if you notice carefully, B and C on their own, they are no longer cones. In fact, this is what we call the frustum. Okay, so to obtain a relationship for all 3 volumes, we have to first look at them in a similar volume solid before we can split them into A, B, and C. So what you are really supposed to be looking at to form a relationship is the cone A and B together to form a second cone, and the cone A, B, C together to form a third similar cone. Okay, so not to look at them, the frustum individually yet. So to form a ratio of the volume of these 3 similar figures, solids, I'm going to write volume of A is to volume of A plus B is to volume of A plus B plus C. And because they're similar, I'm now going to link up their corresponding heights that is given and make a cube relationship. So the height of volume A is given to be h, or 1 unit, okay, cube, A plus B, the whole thing, the height will be 2 units cubed. And A plus B plus C, the entire height would have been 3 units cubed. So the volume ratio across the three similar figures will be 1:8:27. So by looking at these three ratio, we can now find the volume of A, volume of B, and volume of C by doing a subtraction. So volume of A, let's start with the 1 unit that is here, so unchanged. But in terms of the volume of B, I will no longer write 8. Instead, I will write 8 minus 1, which is just the volume of B, so it's 7 units. And to find C, I will simply use 27 minus the volume for A plus B ratio, 27 minus 8, and therefore I will get 19 units. So this is the answer for part A. Now we will look at part B. Part B is looking for the base area of the three shapes A, B, and C. Okay, so I'm going to erase this to make some space. Okay, now if you look at part B, the base area of A, B, and C, they are really just the circular portions of the cone at the bottom. And if you look at what shape they are basically just circles. Even bigger circle. Okay, so these circles are similar shapes. Since the bases, they are all similar figures, and this is regarding the area, I'm going to link up the similar area ratio for the three base. So I can say that the base area of A is to the base area of B is to the base area of C. Okay, they are actually just our circles. In this case, I just need to look for a corresponding length to form their area ratio. Corresponding length that I really have here is just the height. Okay, so this is 1 unit for the height, 2 units for the height, and 3 units for the height. Okay, so by proportion, I can also say that the base area of each of the circle is 1 square is to 2 square is to 3 square. So the 1, 2, 3 comes from a corresponding length that we have, which is height. So to simplify, the final answer will be 1:4:9. Now let's look at part C. Okay, for part C, they mention about the volume of the entire cone to be 540 cm3, and later they want us to find just the portion of the frustum for part B. Okay, so regarding to volume, we have actually already found something from part A. So let's make use of part A to help us in part C. The volume of A is to the volume of B is to the volume of C is bound to be 1:7:19. Okay, so if we add up all the units, the entire volume would be 1 plus 7 plus 19, which is our 27 units. And this 27 units actually represents 540 cm cube. So since we now have to look for the volume of part B, and part B is only 7 units for volume, so therefore by proportion, we can find the volume by using 7 over 27 times 540, and therefore for 7 units, the volume of B will be 140 cm cube.